Welcome students to SB Maths class. We are discussing about the lines and angles. Already 2 videos I have made. I will give the link at the description box below. You will just follow those links to see the previous videos. I have told you at the previous videos, that is, in the geometry part, actually class 9, the 60% syllabus is of geometry, not the 60%, 70% syllabus is from the geometry, and lots of theorems, lots of examples, lots of applications of the theorems, those are there. And if we want to cover all of these, then 1 year is not enough for this syllabus. Okay, so what we are doing here, we are just covering the most important theorems and the applications, also the examples from those chapters. From the lines and angles, in the previous video I have shown you, I have discussed about the different types of angles made by two parallel lines and a transversal. Now we will do some applications of those concepts. We will do the most important applications. 4 or 5 examples we will do, and I am sure about it, that is, most of the times at your exams, from those examples you will get some common. Other examples are also very much important. Whatever the book you have, the R.D. Sharma or R.S. Agarwal or M.L. Agarwal, whatever the book you have, you will just follow all of these examples there. But I want to just give a clear concept, overall concept of this chapter through those examples, because why those examples are important, because here most of the concepts will be used. That's why we will do those examples. Okay, the first example I have written over here, I am reading for you. If two parallel lines, actually this is the sign of the parallel lines. If two parallel lines are intersected by a transversal, prove that the bisectors of the two pairs of interior angles enclose a rectangle. This is a theorem. Also you can say the application of the concepts. So how to do a theorem? Actually this is class 9, and from here the theorems of the geometry has been started. So this is the statement. If you want to write in exam, if you want to write the statement, you can write if the time is there. Otherwise, no need to write that statement. But for your benefit only, I want to say, that is, write the statement, because that is the form to prove a theorem. Statement, after that what comes? The diagram. This is the statement. Then the diagram. Whatever the informations are there, you have to draw a diagram by those informations. Here two parallel lines are there, so we will draw two parallel lines. One transversal is there, I have drawn the transversal also. Now what they say, that is the bisectors of two pairs of interior angles. So interior angles means those two pairs and those two pairs, those are the interior angles. I have told you at the previous video. So two facts I want to say, that is, you will draw with the scale. Obviously here some slanting lines, some curved lines are there. Actually I have not used the scale. You will use the scale. Actually what I want to say, that is, sometimes whatever the informations are given over there, those are not sufficient to prove the statement. Actually we need the help of other diagrams, other lines or other angles or whatever it is. So you have to check, that is, those are sufficient, you can prove with this or not. And also logically you have to proceed. Here I have drawn this diagram. From here what we have to do, or another important thing, that is, you have to write the description of the diagram. This is most important for the exam purpose also, that is, you have to say whatever you have used here. Here what is the description? That is, let AB and CD, I am not writing, just here. Let AB and CD are two parallel lines or be two parallel lines and PQ is the transversal. Now EG, EH, FG and FH are the angular bisectors of the interior angles of these parallel lines. We have to prove. Here I am writing this one. You have to write, must write this one. We have to prove. That is, you have to write the target, what in which target you are proceeding. That is EGFH is the rectangle. This is your target now. Okay, so we have to proceed with this target. Students, I have erased the statement and other things because the shortage of the space. Here to prove EGFH is a rectangle. Now what's the definition of the rectangle? You have to just arrange the logics in that way. See how I am thinking. Actually this thinking will help you to prove the other theorems also. Lots of theorems and technical and tactical laborsome theorems are coming at their way only. Okay, just they have started here. So the proof, here you have to prove the rectangle. So what is the definition of the rectangle at first? Definition of the rectangle is a parallelogram whose one angle is 90 degree. A parallelogram whose one angle is 90 degree. Now what is the parallelogram? Parallelogram means the closed geometrical figure with opposite sides are parallel. The closed geometrical figure with opposite sides are parallel are called the parallelogram. Now whenever the parallelogram, the one angle of the parallelogram is 90 degree, then and there it will be the rectangle. So first of all we have to prove EGFH is the parallelogram. Okay, so for proving this one, let us see how we will just apply the concepts what we have gained from the previous part of the chapter. Here let's see, AB is parallel to CD, it is given, and PQ is transversal. Here you can use EF also, no problem, except of PQ. Okay, so angle AEF is equals to angle EFD. This angle AEF, this angle is equals to this angle. Why? Because those are alternate interior angles. You have to write those logics. There are some numbers, there are some marks for these logics. If you don't write those logics, 1 or 2 marks will be deducted. Mind it, if it is a 3-mark question and 2 marks are deducted for not writing the logic, if you have written all of these steps but not writing the logic, then what will be there? Okay, so write the logic, very much important. AEF equals to EFD, those are the alternate interior angles. So obviously if we multiply half at the both sides, AEF equals to half of angle EFD, then what we are getting? Those are the angular bisectors. GE is the bisector of this angle and those are the angular bisectors. It is given in the statement. So from those we can say this is equals to this angle and this angle is equals to this, because those are the half angles of those. So here angle AEF, half of angle AEF. So we are taking GEF now. Angle GEF is equals to angle HFE. HFE E. I am saying step by step the proof, the logics, what I am using. That's why I am going slowly. Again, if you have any doubt, then pause the video. Obviously, you have to write those steps. Pause the video. Also, you can rewind the video and listen or see. Angle GEF equals to HFE. Why we have not taken the outside angles? Because no requirement is there. We have to discuss or we have to work over this figure only, the blue figure, that is we have to prove that blue figure is a rectangle. So why we will take the outside angles? We have to take the inside angles. That's why we have taken GEF is equals to HFE. Also, if those angles are alternate interior angles when those two angles, which angles we have taken, the red ones, this angle is equals to this angle we have taken. So when those two angles can be the alternate interior angles, wherever EG and HF will be the parallel lines and EF will be the transversal. I repeat, those two are alternate, those two are angles, equal angles. Also, from the figure we can see those two have the possibility to be the alternate interior angles. When those will be the alternate interior angles? When GE is parallel to FH and EF will be the transversal. So I am writing that condition when EG is parallel to FH and EF transversal. So from here we have got the result, that is what is required actually, that is EG is parallel to FH. With the similar logic, whenever we will take EH and GF at our consideration, at the similar logic we can say those are also parallels. So by similar logic or similarly, straight away you can write similarly. Similarly, EH is parallel to FG. Whenever you will see the similar logics are used to prove another part, then just you can write the similarly. Similarly you can prove. Now let us come. So what? From the figure, if this is number 1 and if this is number 2, so from 1 and 2, what we can say? EG FH is the parallelogram. This is the short notation of the parallelogram, parallel lines and LGM. So from 1 and 2, that is opposite sides are parallel. I have told the definition of the parallelogram. So opposite sides are parallel. So obviously this is the parallelogram. Now whenever we have proved those are the parallelograms, this is the parallelogram. What we have to prove? That is, the next proof is we have to show that is one angle of this quadrilateral or parallelogram is 90 degree. For this, now actually it is given. Now angle AEF plus angle BEF is equals to 180 degree. Why those are 180 degree? Those are the linear pairs. Just see, actually that time I have forgotten to say another type of angles are coming here also. So 5 types of angles are coming. That is the linear pairs. We are getting lots of linear pairs. Just see, those two angles are linear pairs. Those two angles also, those two and those two. So those are the linear pairs. Here you have to write the linear pairs. Okay. Angle AEF and BEF are the linear pairs. So those are the supplementary also. Again, multiply with half. So here at the right side it will get 90 degree. Half of angle AEF. You will not take the outside angle, the inside angle. So GEF. Half of angle AEF is coming angle GEF plus half of angle BEF. BEF is there, half of angle, the inside angle. So HEF. Angle HEF. I repeat, if you don't understand, then pause the video, rewind the video and again see the steps, you will understand. I hope you can understand. So this is equals to 90 degree. I have taken the inside angles. This angle and this angle. Those two angles I have taken. This is 90 degree. So now what we are getting? If we combine those two angles, we are getting GEH. So angle GEH is equals to 90 degree. So this total angle we are getting, this is 90 degree angle. So if we say if it is conclusion 3 and it is conclusion 4, so from 3 and 4 we are getting, that is E G F H is the rectangle that has been proved. What we want to prove, that has been proved here. Okay, so this is the way to prove a theorem. You have to write those statements, those parts, that is a statement, then the diagram. If the construction is needed, that is except of the informations, other informations you want to put there, and then the total proof. Okay, write this proof at your copy, practice again and again. Most important theorem or most important result from this chapter. Another proof I will do today. Students, another example. Actually this is the exercise problem from Agarwal book. You can find at the exercise 7b, I think. The exercise is here. Two parallel lines AB and CD are given over there, and those type of figure is there. From this figure you have to prove, that is angle P plus angle Q minus angle R equals to 180 degree. How to prove this one? We need to apply our concepts regarding the parallel lines and the angles made from them. So just see here, actually those informations are not sufficient to prove this one. I have told you, that is, if the informations are not sufficient, then you have to write, you have to put another information, and actually the logical information, whatever it is coming at your mind, you cannot put like that. Logical information. So that is the construction. That point is the construction. What we will construct here? We will just draw one parallel line HI. Draw one parallel line which is passing through this one name is given over there. The name is F, which is passing through F. I am writing draw HI parallel to AB and parallel to CD, obviously passing through F. Okay. Now what is being happening? Why this will help you? to prove this one. Just see. Proof. From here, what we are getting? Angle P plus angle EFH. How much it will be? It will be 180 degree. Which two angles we have taken? Angle P is obviously this one. Angle P plus this angle only. Why those are 180 degree? The sum of those two are 180 degree because those are the what? Consecutive interior angles. I have shown you at the previous video. Consecutive interior angles are the supplementary pairs. So those two are the supplementary pairs. Also, I am giving number 1 here. Also, now angle HFG plus 180 degree minus R, angle R is also equals to 180 degree. The similar logic, consecutive interior angles. What we have taken? Those two angles. This angle HFG and this angle. Those two blue angles, those are also consecutive interior angles. So, now joining those two, 1 plus 2, what we are getting? Angle P plus angle EFH plus angle HFG plus 180 degree minus R equals to 360 degree. Just add those two. Angle P is here. Angle EFH. So angle EFH is this one. Angle HFG. Angle HFG is this one. So total the angle Q we are getting here. So angle P plus those two you are getting Q here plus 180 minus R. We are taking 180 at that side. So minus R will be there. Minus angle R equals to 360 degree minus 180 degree. So we are getting 180 degree, which was our target. So we have proved our result. So in this way, very easy, very easy. Just apply your concepts, apply your brain. Actually, whenever you will see some statement and try to draw the figure of that statement, then your head and your eyes will say you something. That is, in this way, if we proceed, then we can prove this theorem. So you have to arrange those logics. Whatever the information, if outside information is required here, what I have done, that is this parallel line I have drawn here, that was not there, but that has been helped us to prove this one. So this type of outside information is required. If then you can apply those, you have to write those also, and then just arrange the logic in the logical way and you will get your result. Very easy. Just tactical and technical. Okay. Be smart in mathematics. Thank you, students. If this video is informative to you, so please subscribe my channel. Press the bell icon to get the future updates, and also please give a like and please share this video so that your fellow students of other schools also get helped. Thank you, students.